Good day, everyone. Welcome once again to our session. Today, we are going to continue our discussion on the integration by partial fractions. So last time, we had already solved three examples, and this is our fourth example. So we're given here this integral. We have integral of x to the fourth plus x cubed plus x squared plus 1 divided by x squared plus x minus 2 then times dx. Now if you are going to inspect the numerator and the denominator, so we can see here that the degree of the numerator is higher than the degree at the denominator. So as what we've done in our example number 3, we're going to do the polynomial division first before we proceed to what we had done in our first three examples. Okay, so after doing the polynomial division, so the result will be something like this. So the integral becomes integral of x cubed plus 3 then plus minus 3x plus 7 divided by x squared plus x minus 2, then everything is multiplied by dx. Okay, so that's the result. If you're wondering where we get this expression, then as mentioned, we have to do the polynomial division. Okay, so I'll just give you the brief solution here. So we're given here x to the fourth plus x cubed plus x squared plus 1, and we divide it by x squared plus x minus 2. Okay, so we have here x squared, we have x to the fourth, so we can try x squared. So if we have x squared here as the quotient, initial quotient, so we have x squared times x squared, so this will be x to the fourth. Okay, then x squared times x, so that is plus plus, so that it will be plus x cubed, then minus, we have x squared times minus 2, so minus 2x squared. Okay, and then you subtract. So when you subtract, this becomes 0. Okay, and this one is also 0. So this becomes positive. Okay, so this becomes plus 3x squared, then plus 1. Okay, and this divide by this one, so we have plus 3, so 3 times x squared, so we have 3x squared, then we have 3 times x, so that would be plus 3x, and 3 times 2, negative 2, so minus 6, so this becomes 0. Sorry, we have 3x here. Okay, so we have plus 3x, this becomes minus, right, because so minus, so this becomes 1 minus, this becomes plus, so plus 7. Okay, so this is the quotient, this is the remainder. All right, so we know that if this is the remainder, then we have to divide it by the divisor, which is x squared plus 1 minus x squared plus x minus 2. Okay, so that's why we have here This is the quotient. We have x. Sorry, this is x squared. I'm sorry, class. This is x squared. No, from the result, so this is x squared. So x squared plus 3. Alright? And then we have here the remainder. So, sorry, this one. The remainder is minus. Okay, so this is the remainder. Minus 3x plus 7, which is this one. Okay? So this is the one. And this one here, this is the x squared plus 3 from this expression. Okay? I hope you still remember how to do it from our algebra before. So that's one of the important things that we had done during our time that we study algebra. Okay, so we can rewrite this, or before we express this in terms of a and b, we have to express this in terms of its factors. Okay, so this is equal to the integral of x squared plus 3, then plus minus, so this will be minus, or we just consider the plus later na lang. We'll do it negative later on. So x squared plus 3 plus the whole thing here, which is minus 3x plus 7, then divided by the factors, the factors of x squared plus x minus 2. So by factoring, so we have x plus 2. Okay, and then x plus 2, and this is x minus 1. Alright, so these are the factors, and times dx. Then expressing this in terms of a and b, so we have integral of x squared plus 3, then plus we have a over x plus 2, then plus b divided by x minus 1. Then everything is multiplied by dx. Alright, so like in our example number 3, we can focus our attention for this part. Anyway, this can be integrated individually, x squared, integral of x squared dx, then plus integral of 3 dx. Then we'll just combine everything later on. So we'll just focus our attention to this one. So we have this part. Okay, so we'll take this part, class. So this one, we have to equate it with this. Meaning this part here, we have to equate this with this one. So we have minus 3x plus 7 divided by x plus 2 times x minus 1. Okay, this is equal to this part here. We have a over x plus 2, then plus b divided by x minus 1. So finding the LCD on the right side. So we have here the LCD x plus 2 times x minus 1. So this LCD divided by this. So what is left is x minus 1, then times a. So we have a times x minus 1, then plus. So this is plus, so this is also plus. So this LCD divided by this x minus 1. So what is left is x plus 2, then multiplied by b. So we have b times x plus 2. Alright, then just copy the left side. So the left side is 3x plus 7, then divided by x plus 2 times x minus 1. Okay, and then equate the numerators. So we have to equate this with this one. Okay, I will write it in the other board. So we can say that minus 3x plus 7 equal to, so we equate these numerators, equal to a times x minus 1 plus b times x plus 2. Okay? Then after that, let's solve for the value of a and b by setting the value for x. So how to solve for x? So to solve for x, we need to equate these factors. Equate these factors to 0. Okay, so I will write it here. So we have the factors x plus 2 times x minus 1. So equate this to 0. So we have x plus 2 equal to 0 and x minus 1 equal to 0. So solving for x equal to minus 2, the other one x equal to 1. Alright, so we have here two values for x. Okay, this one and this. So these are the values that we're going to substitute in our resulting equation. Okay, so from here, from this equation, so when x is equal to, we have two values equal to this one. We have x equal to minus 2 and x equal to 1. So we'll start with minus 2. So when x equal to minus 2, so substitute this value to this equation. So we have minus 3 times minus 2 plus 7 equal to a times x is minus 2 minus 1 and plus b times x equal to minus 2 plus 2. Alright, so this part here, this is 2 minus 2 plus 2, 0 times b. So the whole thing here is equal to 0. Okay, so what is left is we have minus minus. So negative 3 times negative 2 is positive 6 plus 7. So this is positive 13 equal to minus 3a. So from here we can solve for a. So divide both sides by negative 3. So therefore we have a equal to, our a is equal to negative 13 over 3. Alright? So this is our a. Now in, okay, I'll use this space here. So when x is equal to, the other value for x is equal to 1. Okay, so when x is equal to 1, so substituting this value in this equation here. So we have minus 3 times 1 plus 7 equal to a times x, which is 1 minus 1, then plus b times x, which is 1, then plus 2. So we have minus 3 plus 7 is positive 4. So this becomes 0, right? Because 1 minus 1 is 0 times a. So the whole thing here is equal to 0. Okay? So what is left is we have minus 4 on the left side. We have 1 plus 2 is 3 times b, so 3b. So from here we can solve for b. So our b is equal to, divide both sides by 3. So we have b is equal to 4 over 3. Okay, so these are the values for a and b. And then let's go back to the equation that contains our a and b. Alright, so we have to go back to this equation class. Okay, I will rewrite it. So our equation is, okay, so we have integral of, okay, I'll make it a little bigger. So integral of x squared plus 3, then plus a divided by x plus 2, then plus b divided by x minus 1, and everything is multiplied by dx. Now we have the value of a and b, so substituting. So we have the integral of x squared plus 3 plus our a is minus 13, right? Our a is minus 13 over 3. Okay, so minus 13 divided by 3, then divided by x plus 2. Then plus our b is 4 over 3. Okay, so our b is equal to 4 over 3. Then divided by x minus 1. X minus 1. And everything is multiplied by dx. Similar to what we have done in other example. So we can rewrite this as, we can integrate each term individually and then apply the rules of division of fractions. So we can write this as the integral of x squared dx. We distribute the integral sign, also the dx on its term. Then plus integral of 3 times dx. Then plus, this is the constant multiplied by dx. So we can put the constant on the left side of the integral sign. So this is minus 13 over 3. And integral of dx over x plus 2. Okay, and then plus, so the same as this one. So this is a constant multiplied by dx. Put the constant on the left side of the integral sign. Then dx here, and divided by the denominator, which is x minus 1. Okay, so we are now integrating each term individually. For the first term, or before that, let's see if we can still use this formula class. We have the integral of du over u, which is equal to ln u plus c. Okay, so let's try if we can still use this. So here we can let our u be equal to x plus 2. So therefore, this is x plus 2. So our du is equal to dx. And similarly, we have our u here is equal to x minus 1, and our du is equal to dx. So we can say that when you do the substitution, so we'll have the expression here, integral of du, because our dx is equal to du, and this is our u. We let this be equal to u. So we have now in the form of du over u. So we can use this integral of du over u is equal to ln u plus c. Okay? And here, integrating the first term. So our first term, integral, so we use the power rule, power formula. Okay, so what's our integral of the first term? So the first term, using the power formula, so it becomes x cubed divided by 3. Okay, so the integral of the first term, and the second term, integral of 3 dx, so you can put the constant also outside, and then integrate dx, which is equal to x. So this is plus 3x, then plus minus, so this will be minus. So minus 13 over 3, then integral of this in the form of d over u. So this is ln. ln of our u here is x plus 2. Then plus, we have 4 over 3. Then this is also ln. ln of x minus 1. Then plus c. Okay? But we can still simplify this one. So how to simplify that one? So we can combine. Do you have something to combine? So you can simplify this if you want, or you can retain this as is. Okay, so let's check now. We have x cubed over 3 plus 3x minus 13 over 3 times ln x plus 2 plus 4 over 3 ln of x minus 1 plus c. So this can be our final answer. If you want to combine using the logarithmic rule, we have ln. So the logarithmic rule is ln m minus ln n. So this is equal to ln of m divided by n. Now, like for example, this one, you can combine this. Common here, you can factor out common, which is 1/3. Okay, so you can rewrite this as x over 3, or you can factor even the 1/3 here. So you can have 1/3. Okay, then you have x cubed okay, so no need, no, we can just leave this first two terms. We just factor the common here. So we can rewrite this as 1/3 x cubed, then plus 3x. Then you may factor 1/3 here. So if you factor 1/3, because we have a common here, the fraction, this part, and also this part. So denominator 3, so you can factor the 1/3. Then you can start with the plus. So 1/3. Okay. And then this is ln. So start with this one. Sorry, we still have 4, no? We still have 4. So 4 times ln of x minus 1. Then minus, we have 13. Then ln of x plus 2. Then plus c. Okay? And then you can use this logarithmic rule to combine these two. Okay? So how to combine that? So try to explore, class. No? Just look at the previous examples. Okay? So explore using this and simplify this one, class. Okay, thank you very much, and I hope you have learned something today. And in our next video, that would be will be about the application of the integral calculus, class. So I would like to end my discussion about the procedures of doing the integration using different methods. I hope you've learned something, and I hope you can use them in our problem solving later on. Thank you, and bye for now.